This probably won't take all of the give you guys a few minutes to get started on what we have this evening. What we've worked through so far today with this, or in the other class, was that we're going to start figuring out ways. What we're looking at here is ways in which that we can make our lives easier by showing that things might be similar and fewer steps. What I mean by that is, up until this point, when we had similarity statements, we had to know that we had all angles that were congruent. We'd have to have all sides that were all sides had the same ratios. For example, if we're talking about triangles, if we had triangle ABC, and we said that it was similar to triangle XY and Z, we can make our list of the three angles. Because this had to be true by definition. We know that by just looking at the lettering of what we call a similarity statement, is that the letters tell you specifically which angles match up with which angles. This goes for all shapes. It just so happens when you have a triangle, it's just a little bit quicker. Okay? We also knew that then if they were to be similar, that all we had to do was follow the lettering of the statement, if you will, and we wrote out ratios. AB, BC, and then CA coming back. What was yours? Como se va? Excelente. Gracias. Anyway, how do you say how are you in Portuguese?
¿Cómo estás?
What was that again? Oh, sorry. Como? Você? Está. So it's really close. And then thank you isn't gracias, it's obrigado. Obrigado. It's almost Italian. It's very close. What? No.
Ni hao.
Sorry, I didn't mean to put you on the spot. So, according to what we did yesterday and the day before, we started talking about these things called similarity statements. All we had to be able to do was look at the lettering. We could come up with which angles had to match up with which angles. We were able to come up with which sides match up with the other sides in order to show that what do you call it? Those ratios might not be equal. Well, just like when we did triangles, when we proved triangles that were congruent 6 months ago, 3 months ago, we started with having to prove that all the angles were congruent, all the sides were congruent. And then after that, we started peeling back a lot of the layers of things we had to show. It goes the same way when we start talking about this thing called similarity. You don't have to show everything to say that the two triangles might be similar. And that's why when we get into the triangle portions of this chapter, basically these last three sections, it goes by a little bit quicker. That being said, I know that I've been having up on the board here like the little short quiz for tomorrow. I'm still planning on it. It is literally a really short quiz, so it's going to be a real nice, easy thing for us to get into to go into the weekend with, and we don't have to worry about any homework and all that other junk. The stuff that we're doing today will be on there, but and then we'll have a good 5 minutes, a quick review of it before we take the quiz off. I don't see this being a big issue at all, just so you guys know. But what happens here is that when you're talking about being able to prove triangles, when we prove triangles were congruent, we had that what we call that alphabet soup, where we had side, 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 side angle, side, and so on and so on and so on and so on. Well, with the similarity, there's only three. You have what's called angle, angle, similarity, side, 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 similarity, and you have side, angle, side, similarity. And what we're going to do today is show what each one of those
looks like and how you're able to decipher which one you have or which one you don't have to show that something works. It is pretty darn simple, to be honest with you. Excuse me. So one of the reasons why we call it that angle, what that stands for is that you have two angles between two triangles that are congruent to each other. So if I talk about this thing called, can I go to a clean one? I'm just going to talk about each one of them. Is that okay? So if I do this thing called angle similarity, what that means is this. You have two triangles. You have two triangles, and you get two angles within the two triangles that are congruent. If you have two angles that are congruent between two different triangles, the triangles are similar. Dun, dun, dun. That quick. Because honestly what happens here is that if, let's say for example, angle A was 40 and angle B was 60, that makes this 40, and that makes this 60. What does this angle have to be? 80. So it means that these two angles have to be congruent because we did a theorem a long time ago called the third angle theorem. Do you guys remember that one? We didn't use it a whole lot, but all that means was, bless you, all it means is that all three angles in a triangle always have to have to be 180. If you have two of them that are the same, it always works. So this is why we had that. So what happens here is if you get two angles that are the same, the sides wind up being proportional. They have to be. Okay. So you wind up with being able to say that triangle, just following your letters, and this you say it by, that's all that means. There's no proof here. There's no statements and reasons. What you're going to see a lot of times with these types of problems is angle pair relationship stuff. What I mean by that is you're going to see parallel lines with transversals. You're going to see vertical angles. You'll see a lot of stuff like that. That way you're able to take information from a given diagram to show whether or not something is in fact congruent. You know how to take information from a diagram. That's not an issue. What's going to be an issue is can you keep the lettering straight? Okay, and that's what we've been kind of working on. For example, if I have a good old-fashioned bow tie picture. What do you have in the middle here? You always have vertical angles. You know you have vertical angles here. If these two guys happen to be parallel, isn't this a transversal? Isn't the other way a transversal? So you wind up with alternate interior angles, so you get angle right away. I think we had an example of that yesterday, didn't we? Where we had to go through and follow which way the tick marks were going. That's really the most complex thing out of this is after you know what you have, can you follow the tick marks around correctly to get the right ratios of sides? It's not super complicated or anything like that at all. What? How much you want to bet tomorrow at 9 o'clock with Bella rings? See how it rang today at 9 o'clock? You know why it rang at 9 o'clock today? It's finals. Someone forgot to turn off final schedule. Do you think they remember to turn off final schedule for tomorrow? True. So they have to reset it for the assembly thing, but will it work? It's always fun to guess on these things. Anyway, sorry. Next one. The next one is what we call side-side-side similarity.
one is more of the ways of showing that something is similar. This is the one that takes the most work. Yeah, you know what? You've done this already. You've done this one already. In order for it to work with this whole side-side-side thing, what you wind up having here is, excuse me, if the sides excuse me, if all three sides, AB, BC, CA, if the three sides have the same ratios, then they're similar. Okay, that's really, and you check this a lot. And it's a matter of, you know how we did the one example yesterday on that 6.3 worksheet where it said the sides were 10, 14, and 20, and the short side of the other one was like 12, figure out the other sides. It's the idea that you take like a small, a medium, and a large side of one side and match it to the small, medium, and large side of the other. Okay, it's just the same thing that we've done where you take all your side lengths of the image that you have on the left, put those in a numerator. Take all the side lengths of the image of the one on the right, put those in the denominator in that same order in which you put them before. I always say go from small to large, because that's kind of how you think in terms of how you count. But as long as you're consistent, it's okay. So if all three of those ratios work, then your triangles would then be called similar by side, 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 similarity. Once again, don't worry about the fact that you're not doing any proofs. It's just the idea that can you match up side lengths to work correctly in order to show that they all have the same ratios. That's the thing that we're looking at being able to accomplish. Oh, excuse me. Bam.
Okay, so there's going to be numbers instead of letters?
Yeah. We're getting there. You all right, Bill? Worried about you there. If you were like fishing in your mind and you were trying to catch something. You know what was the craziest thing my kid caught? I think it was never go off on a tangent ever. One of the craziest things my kid, we go fishing whenever we go camping, whenever we go place. We go up to Minocqua a lot. Place we stay, they have a right there on the lake, so kids are always fishing. One of the things he caught last year, might have been the year before, but he just goes out there and he casts. He literally, legitimately hooked a dragonfly on a cast. I'm not kidding you. I have a picture of you know how the size of a dragonfly? They're not that big. Our oldest son has you guys know the difference between an open cast reel is? The cast it hangs on the bottom instead of the push the button cast. He uses the open cast because he thinks he knows what he's doing. Won't take the fish off the hook yet, but he's still working on it. But he went out there and he cast and he threw it towards the weed bed and he was coming back. And when he brought it in, he pulled it up. He's like, "What's that on my hook?" He hooked a dragonfly. It was the craziest thing. And I mean, the dragonfly is smaller than my thumb, so imagine the possibility of that happening. Yes, sir. I have to dig it out. I'll show it to you. I got to dig it out, but I do have it. It is legit. Yes, sir. I've done the I've seen the frog. We've caught. I know. What did they catch? Was it a frog? They've caught each other. I've had my kids hook each other. Yes, ma'am. I didn't hear all that. What's that? Yeah. We do a lot of stupid stuff with fish. You know, I've seen some crazy stuff. But yeah, it's always fun.
Let me show you one more, and if we get a chance here, I'll try and dig out that picture. I'm not lying. It was legit. It wasn't staged. It's pretty cool. The last one is what we call side angle side similarity, and just like when you had side angle side before, when you had side angle side before, what did that look like in a diagram? Where was the angle? It was in the middle, and it was between the two sets of sides that were congruent. Well, in this case, the angle is going to be in between the two sides that have the same ratio. So it is pretty similar. Oh, I hate using that word. It's pretty much the same generic setup as you've seen. So if I say it's angle C and angle Z happen to be congruent, then that means that, excuse me, AC has to go to XZ, and BC is to YZ. What's happening here is that the two sides that make up the angle have the same proportion. They have the same ratio. So it's very similar to the idea of side angle side, but we're looking at it in terms of the ratios instead. Now, when you're looking at these in terms of examples of what things look like, it is really easy to decipher which one you're going to use. And quite honestly, you guys have already done some of these style problems. For example, I think yesterday we had an example in class. We had an example in class that was kind of like this, and it had the two angles here and here. Now that one, remember how I showed you that there was a large triangle and a small triangle? That large triangle happened, and the small triangle happened to share that same one. That's why that worked, because of angle. What we said was this was a small side, this was a medium side, that might have been the large side, I don't know, would correspond to the small, the medium, and the large, depending upon the numbers. It was why that worked. For example, are those guys going, are those two figures going to be similar? Guess what? Angle angle. It's because of angle angle. One of the things you can do here is, obviously around point S, you get vertical angles, correct?
Yeah.
Okay. Since R and B are congruent, what do you know about segments RW and VB? Parallel, very good. They're parallel because angles R and B, bless you, happen to be alternate interior angles. So if the angles if alternate interior angles are congruent, then you know that you've got lines that are parallel. It's one of those things that we've talked about before that just kind of shows back up from time to time. So this would be an example of what if you were asked to say how are they similar, you would say, oh, they're similar by angle. Oops. And then I would ask you to write out the similarity statement. So if you wrote out the similarity statement, that means, well, I'm going to go R, S, W. What would be the corresponding letters for the other one?
Yeah.
Very good. That's the idea of how this works. Can you identify how they can be similar? And then can you write the statement? So some of these times you do a little bit of work. Here all you have to do is mark a diagram. Some of the times you have to actually write out ratios. Okay? I have some examples I want to mark. And I did it on a worksheet this time, so you guys have to write down different triangles. Well, yeah, thank you. Yeah, we did. I'll grab it in a second. Here, ladies. Welcome. So, what I want you to do, well, they'll get there. I try to be guessing, you know. I am, if not, just, you know, Mr. Crazy. Nope. Just some extra examples. What I'd like you to take a minute here, let's take a few minutes and let's do 3 through, well, just do 3 through 6 real quick. Then we'll do an example, then I'll write out the example of what it looks like with the next sides, and then go on from there. So let's just take a couple minutes, check it, we'll do a couple more, check it, and go on and on and on and on. All right? These should be pretty easy. When you're looking at number 3, all you have to worry about is you got to figure out what angle S and angle H equal. Well, one of them equaled 51, the other one equaled 39. Therefore, did all of it work? Yeah, and then it's just writing out the statement. Now, hopefully by now that's pretty simple. And 4, did that work? No, because the angles didn't match up correctly. You just had to subtract out. What about 5? Same deal. You had to subtract out and go. So there's very subtle nuances to try to be able to set these things up. But as you can see, now what I want to do though is skip down here to number 7 real quick, and I'll give this back to you in 1 second. Now I'm looking at number 7, and I need to figure out which one. What I have here, I have 9, 27, 13, 25, 21, 14, and 42. Now, one of the dead giveaways for deciphering whether or not it's going to be angle, angle, side, 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 or side, angle, side is what information they give you to start with. Well, in this case here, they're giving you all 3 sides, which means you have to check it via that method. Now, if you're going to check that, the easiest thing to do is to take all the sides from the one on the left and put them in order. What I mean by that is just doing 9, 13.5, and 27. And then I check that to what the corresponding small, medium, and large would be on the triangle on the right. Does that make sense by doing it that way? It's usually the easiest way to think that way, because you guys can think sequentially. It doesn't matter what the shapes look like, if they're flipped, rotated, and done anything to it. But if you're able to just know that 14 is smaller than 21, you should be okay. And then you just check it in the calculator. And when you check it in the calculator, some of these might give you decimals, some of them might give you fractions. As long as they're always the same decimal, or as long as they're always the same fraction, doesn't it work? Yeah. So if I check that, see, 9 over 14, 13.5 over 21, and then 27 over 42. Hey, look at that. They all find to be in the same. It's 0.64 and change. So this would be a yes, side, 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 and then, I forgot my letters. I should have my own. If I'm looking at it, then I would say it was K, N, R for triangle was similar to triangle DES. It's just a matter of following the letters as you're writing it out. If you look at the next one, the next one's a little bit different. The next one is a little bit different in the fact that you have to decide where to start, really. This one is kind of like the image we have over there. And here's what happens. We have 20, 8, 56, 40, 6, and 15. Do you guys agree that you have a small triangle and a large triangle?
Yes.
If I use the small triangle first, what's the smallest side of the small triangle?
15.
It goes 15, then what? Then 15, 20, 40. Now, to correspond to that for the other one, what's the shortest side of the largest triangle? It's 21. The whole thing is 21. Okay. See how that goes? So from time to time, you might have to put two together, or like we did yesterday, we had the whole thing, we had to take a small chunk of it out. It happens. You either might have to add something, or you might have to subtract something. So you have 21, 28, 3, so that's 5 sevenths, 4s, that's 5 sevenths, and then that is 8, so that's 5 sevenths. And then you would just write out your statement. Okay. Look over at 15 real quick. 15 is about the weirdest as they get as far as side angle side. Yeah. This is about as weird as it gets when you have to figure out what you're working with. Notice you've got those two segments, CM and RP, are parallel to one another. Those two parallel lines run into that segment QM. They all run into that top line there. Which means then these two angles have to be the same because they are corresponding. This was the one weird setup that we didn't do a lot of when we did congruent triangles. But notice if you kind of tilt your head sideways, it kind of looks like two flags on top of one another, two pennants, if you will. That's when you have kind of a dead giveaway that you have corresponding angles, when you have two flags, if you think of it like that. So you would check your sides. I would say 22 and 22 is to 20, I'm sorry, small to 33, and then 36, excuse me, 36, 54. You're checking to see if that works. And it does. Terrible stuff, isn't it? Right, says no. What interpretation was like, yeah. So you have the yeah, and she has the no. Just that. You know, it's funny, I was throwing out a whole bunch of old stuff, and I found your sister's picture. Do these in this evening? This should be a relatively straightforward method to do. Now, on this assignment here, guys, make sure you, obviously if you're going to get angle, that's the easiest because all you really have to do is mark up the diagrams. But it asks you to do two things. It says figure out which one you're doing and write out the similarity statement, which means you would have to write out yes by side angle side similarity. And then in this one we had, I forgot the letters, but you would say ABC is the B, D, D, or whatever it was. Okay. So make sure you write out the actual similarity statement itself for each one of those. If there's any scary ones, we'll get back into class tomorrow. We'll do that, and then we'll just take that quiz. Yeah, and then we'll take that quick quiz, and we'll call it a day on this stuff. Next week when we come back, we'll get there's only two more sections. We'll probably be done with this Thursday. Maybe we'll wait till Friday. We'll stretch it. We got nothing else to do. You?
Yes.
You're a little bit off. Not by much.